Hello, I'm Byron Ward, and this is the Bell 525. Today we have the leadership team here with us today to provide an aircraft overview to showcase the 525's modern and clean sheet approach to safety, capability, and comfort. When certified, the 525 will be the most advanced contemporary commercial transport aircraft in the marketplace, not just now, but for years to come. We are anxious to give you those details. In 2020, we made great progress towards certification, finishing out most all drive system, fatigue testing, bird strike testing, lightning testing, and supplier qualification testing. Primary focus to go is flight testing with the FAA in the cockpit. At mid-year 2021, we plan to provide all certification artifacts to the FAA to ultimately achieve type certification. In parallel, we will also be working with foreign authorities, such as EASA, to provide validation as soon as we can after certification. Now I'm pleased to turn the presentation over to the rest of the team.
Hello everyone, and welcome to Bell's Flight Research Center in Arlington, Texas. I'm Josh O'Neill, Chief Engineer of the Bell 525, our latest state-of-the-art helicopter.
And I'm Brendan Lanigan, Aircraft Performance Specialist and longtime member of the 525 team.
We're here today to give you an exclusive inside look at the Bell 525. We will be taking a tour with you around the 525 and visiting with some of our experts who are passionate about the design of this aircraft and how its features are changing the experience of flying for passengers and air crews. Brendan, can you tell us a little bit about the inspiration behind the 525?
Yeah, so as you know well, here at the 525 program, it all starts and ends with a focus on the customer. When Bell began to explore this market, we knew that we didn't have all the answers. Like what's the right aircraft size? What are the right design features? Where can technology really add value to customers? So to answer some of these questions, we brought in a customer advisory panel to explore the art of the possible with us. The influence of that group is seen throughout the entire 525 helicopter that you see today right behind us. Josh, why don't you talk a little bit about what we learned from the customer advisory panel?
Yeah, Brendan, you know, it really was a very exciting time for us at the outset of this journey on 525, and I do think it's unique in terms of customer involvement. The 525 truly started as a clean sheet helicopter design. From the outset, we brought in customer pilots, maintainers, and even future passengers and embedded them with our design teams. As the design was built up from a clean sheet, critical design decisions were validated and sometimes redirected by customer team members. The 525 is a 20,000-pound weight class transport category helicopter with 21st century technology infused throughout the design. It's a fast, smart helicopter. We'll hear today about the fly-by-wire flight control system that makes it easy to operate in all flight conditions, from low speed out to up to 175 knots. We'll hear about the advanced design of the aircraft mechanical systems, designed for safety and redundancy. And we'll hear about the latest in gearbox technology and design for maintenance. All this put together in a collaborative forum with customers with an eye towards the future.
Speaking about the future, Bell and our parent company Textron have a large focus on minimizing the environmental impacts of our businesses as we move towards a more sustainable future. We really believe that 525 will make a difference in future operations. Why is that? Well, first, it's fuel efficient. It burns about 30% less fuel per hour than a typical large offshore helicopter, which results in about a 20% reduction in CO2 emissions per passenger mile. The aircraft can use recyclable consumables like gearbox and engine oils. We also use environmental-friendly corrosion inhibitors. Another important aspect about making a more sustainable, friendly helicopter is noise reduction. The 525 rotor system was designed specifically for that, with 5 blades with swept tips and a variable RPM to reduce the noise during certain phases of flight. This has resulted in a significant noise reduction over heavy helicopters in operation today. In fact, our preliminary certification test data shows that the aircraft is about 3 decibels quieter than the S-92 in most flight conditions.
And that's great, Brendan. Why don't we go have a closer look at the aircraft? Now, one of the first things you'll notice as you approach the 525 are the large windows. These provide excellent visibility for the aircrew and the passengers, and the width is best in class. The windows are also all push-out for emergency egress purposes.
Let's open the door and take a look at the first row of passenger seating.
All right.
So as you can see, both crew and the first row of passengers access the aircraft through these doors. You can really see the first-class legroom available for that front row of passengers. The pilot seats track and rotate for easy entrance and exit from the aircraft. So let's go check out the aft part of the cabin.
All right.
So the first thing you notice about the 525 cabin is this large step right here. The step is wide and textured to minimize the risk of missing it or slipping on it when entering or exiting the cabin. The 525 also has a very wide sliding door, 54 inches in fact. So what that allows is a really easy entrance and exit path for anyone who's in rows 2, 3, or 4 of the aircraft. The cabin was specifically designed for passenger comfort. So we're going to bring in one of our teammates, Doug, who's 6'3" and wearing a survival suit to prove how comfortable these seats are. Hey, Doug.
Hey, Terry.
So at 6'3", you can see how much space he has. Each seat is about 20 inches wide, which is equivalent to a first-class domestic airlines seat. I had the privilege to take a demonstration flight last year, and I thought the seats were very comfortable. We flew for over an hour, and I left feeling refreshed and ready to go. So another important aspect of the interior is the great visibility you have, great situational awareness. With tall open windows all around you, you can see everything and not feel confined or claustrophobic. So with that, with the design of the 525 with 4 rows of 4, means that all you need to do to touch an emergency exit, no matter where you are in the aircraft, is reach your hand out and you can touch an exit. So we're providing a safe exit path for anyone in the unlikely event of an emergency. Another important part of the cabin experience for passengers is noise. So we wanted to provide a really quiet cabin. This cabin feels relatively quiet compared to other large offshore helicopters. In fact, recent measurements that we took on the aircraft showed that it was significantly quieter than what's available today on the market. In fact, it was 4 decibels less at cruise speed than a competitor aircraft we've measured. Finally, the 525 is going to have a smooth ride. We accomplished that by using liquid inertial vibration eliminator system, or a live mount system, to dampen vibrations from the dynamics before they enter the airframe structure. We've used this concept before on the 429 helicopter. It's a fast, smooth ride, especially enjoyed by the corporate VIP market. So it made a lot of sense to bring that technology forward to the 525 and improve the cabin environment for pilots and passengers who are going to be flying this aircraft frequently offshore. So Josh, another important feature of this interior design is its multi-role capability. So here in our 16-seat configuration, each of the seats are mounted on 4 floor pucks. That allows them to be removed easily for rapid reconfiguration to a search and rescue role or a utility role.
That's right, Brendan, and you know many of those missions can take place in challenging maritime environments, and the elements can often be unforgiving. The 525 is also designed for corrosion resistance from the start, with improvements in abrasion resistance for metallic components, corrosion-resistant coatings in vulnerable areas, and priming and painting of exposed surfaces under the floor and up on the roof in a high-gloss white paint. Even the electrical system makes use of composite connectors and corrosion protective compound to protect those components. All of this puts 525 a step ahead in design for corrosion and right off the production line.
Well, I think we've talked enough about the cabin for now. We know 16 people who are going offshore for 3 weeks are bringing a lot of baggage with them. Let's go see how the 525 accommodates that.
All right.
The 525 baggage bay has 2,000 pounds of capacity. Inside this massive storage area are 17 tie-downs for cargo. This has best-in-class volume, almost 50% larger than our competitors, about the same as an S92. The baggage bay door is 46 inches off the ground, providing best-in-class lifting height, giving you better ergonomics for the baggage handlers. We'll also have a ladder available as customizing equipment. The forward panel of this baggage bay would be removed in a SAR aircraft to provide immediate access to whatever mission equipment the crew would like to store there.
Well, Brendan, I think this has been a great overview of the cabin and the passenger experience. Why don't we head up front and talk to our Chief Program Pilot, Troy Caudell, and hear what it's like to fly the 525.
Hello, I'm Troy Caudell. I'm the lead experimental test pilot for the Bell 525 program. I've got over 38 years of flying experience, and 26 of those have been in flight test. I've worked on many programs before, and I feel very fortunate to have been able to be involved with the 525 since its inception. Very early in the design phase, we spent a lot of time in the cockpit, focusing mainly on the human factors and the ergonomics aspects of the cockpit. One of the things that came of that was the sidearm controllers, and I believe that reduces the pilot fatigue significantly. It also enabled us to improve the viewability of the displays in the cockpit, and that enabled us to lower the glare shield, which provides an enhanced field of view for the aircrew. Fly-by-wire is one of the key aspects of the 525 program. With fly-by-wire, you're able to tune a helicopter to fly however you want without extensive hardware or outer mold line modifications. It also provides us with envelope protection. The pilot can be looking outside and the aircraft will cue him on an approaching limit. We also have the 3-loop control-all design. It enables us to provide many flight director functions embedded into the control software, which include speed, altitude, and hitting hold. The 525 flies like any other helicopter, only easier. With the control laws, we have decoupled the typical mechanical coupling that you have in a regular helicopter, and it provides a single axis input for flying the helicopter. Lifting to a hover is very simple. All you have to do is raise the collective, and if you have the altitude hold on, it'll maintain position and altitude and hitting. For up and away flying, we also have an added safety feature called auto assist. In this mode, the helicopter will automatically lower the collective for the pilot and minimize the NR droop. It will also slow down and maintain nominal NR. We've tested auto assist very extensively, and we've developed the profiles based on a single engine failure followed by the second engine failure. So we've tested out to 120 knots, and the system works perfectly. Fly-by-wire also enables us to have various modes for flying. In the 525, the modes transition automatically for the pilot, and they are enunciated on the PFD to inform the pilot of the mode that you're in. The air to ground, ground to air, high speed, low speed, turn coordination, and hitting hold are all automatic, and again they're enunciated on the PFD to inform the pilot of the mode he's in. Starting the aircraft is very simple and takes less than 10 minutes. Basically, you turn on the battery, and after the system does its initial bits, about 15, 20 seconds, APU comes on. Once the APU is on, all the electrical buses are powered, and the crew can start setting up the radios, doing their navigation, setting up their flight routes, and completing the system's test. Once those are complete, the aircraft is ready to start, and basically you just take the COSIF and go to start idle, and the engine starts. The GE engines provide automatic temperature limiting, so you don't have to worry about an overtemp. Once the first engine is started, you start the second engine, and from there, if you've completed all your checks, all you have to do is go to fly, taxi, and take off. With this quick startup procedure, the aircraft can be started on a moment's notice and perform the mission very quickly. The MFD, or the multifunction display, provides the capability to view the various systems on the aircraft. The MFDs are controlled by the GTC, or the Garmin Touch Controller, and is an integral part of the G5000H. To give a more thorough explanation of the G5000H, I'll hand it over to my colleague, Melissa.
Thank you, Troy. My name is Melissa Reinsch, and I'm the Avionics and Electrical Supervisor on the 525 program. I've been with Bell 8 years, and all 8 years have been on the 525 program. I'm here to talk about the Avionics Suite, which is comprised of the Garmin G5000H. It's the brains behind the operation that really talks to the aircraft. It's comprised of 30 plus LRUs, and those LRUs talk to all the different systems on the aircraft and allow us to gather all the data we need to display it to the pilots on the glass cockpit in a thoughtful and intuitive manner to hopefully reduce the pilot workload. So before we get started, I want to kind of give you an overview of the glass cockpit that the 525 has. The glass cockpit is comprised of 4 GDUs, the MFDs and the PFDs. You have 2 inboard MFDs, or multifunction displays, and 2 PFDs outboard, primary function displays. The primary function displays house your primary flight information. In the center here, you can see you have all your airspeed, altitude, your heading, and all that good stuff. And to the right of that, you'll have your crew alerting system, or CAS, which is then ranked warning, caution, advisory, status, and within those there's a hierarchy so that the most recent will stack on top. To the left of that, you have your power situation indicator, or PSI. This is all your engine information, so your total torque, your NGT, your rotor speed, and that's going to be displayed using the pointers. The pointers represent either engine, and the pointer that is in the data that's going to be displayed on your gauge is going to be your controlling parameter or your limiting parameter. And right now, the limiting parameter is NG because, as you can see, it's boxed here. There's many things you can do on the primary flight display to customize it to your preference. Right now, we don't have synthetic vision up, but you can easily turn on synthetic vision by going to your altitude overlays and selecting synthetic vision. On top of that, we can also pull our map from the MFD and display it on the PFD. We can take our traffic map and display it in the right bottom inset map underneath your CAS stack. So that's your PFD. You also have your MFD, which is inboard of your PFD. On the left-hand side of your MFD, you have your EIS, which is your engine indication strip. That has your power plant information that is not required to be in the primary field of view like your PFD parameters. This EIS includes your pressure and temperatures of your engines, the pressure and temperatures of your gearbox, your hydraulic pressure, your gearbox states, a synopsis of your fuel system, as well as the electrical system. And right now we're on the weather map, so you can see that we have the weather map, and if you look at our GTC here, you see that the 525 comes standard with the TCAS system and the HTOS system. And if we go here, we can go into the map setting, and as you can see, we're sitting at the airport right now. And one of the nice things about the half pane feature is I can go here, and if I want to, I can easily pull up a chart of the airport I am at. So I can have the chart sitting right next to my map, and I can zoom in and out on the chart as well as in and out on the map. So there's lots of ways to have it customized to what you'd like to see. So the Garmin system interfaces with, as I said, almost every system on the aircraft. The one that I find the most interesting is the hydraulics and flight controls page. The FCS Synoptic houses more information for both the pilot and the maintainer. The hydraulics, as you can see, also shows the temperature and quantity, where our EIS strip only shows the pressure. And it also gives you a little bit more situational awareness and the fact that you get the gauges there. So you'll see the trending behavior of the pressure, temperature, and quantity instead of just the digital readout, as well as various other parameters. And I think one of the most interesting thing is the representation on the flight control system on the right-hand side of the collective and cyclic, as well as the position of the following. So if I were to adjust the cyclic ever so slightly, you will see that the position of my cyclic moves. You also have your actuators here, so you can see the full extent of those and a much more detailed description of your weight on wheel sensors. Now, as I said, we can go into the engine and drives page here, and this one also has various options that you can select. I'm just going to show here the synoptic on this one as well. This one is interesting because it gives you an aerial view of an aerial depiction of the engine and drives page, and much more detail as well than the EIS strip would to give you. So for the engines and drives, the EIS strip gives you a percentage of the health of those pressures and temperatures, whereas the engine and drives page gives you the actual PSI and pressure readouts and temperature readouts in Celsius. I'm going to go quickly into the ice protection page. We don't have this aircraft kitted with ice protection past the basic kit. So right now you just have your standard, which is the pitot heaters and the static heaters, as well as your engine anti-ice. So you can see on your GTC page that you can control your pitot statics. You can either turn them on and off. So one of the things that makes the 525 unique is that we were able to declutter the cockpit with the electronic circuit breakers. So I'm going to show those here on the display as well. There is quite a few circuit breakers on the aircraft, and one of the things that's really nice about the system here is that you can actually search for the unique circuit breaker that you're looking for. So I can search for any particular system and it'll jump directly to it. So if I wanted to search for the MFD, I would just type that in there, select it, and it will jump straight to the MFD where I can see that it is currently it's not pulled, it's pulling 5 amps. Now I've kind of gone over the basic aircraft functions, the system interfaces, and that's just a significant amount of data that the Garmin system is pulling in and we're displaying to the pilots. One of the things that I find extremely interesting about the 525 is all the things we've done to take that data and make it a usable and quickly maintainable aircraft, so the maintenance side of the avionics suite. So I'm going to go into the maintenance page here. This is the maintenance GTC page. The maintenance system is unique on the 525 and very complex. The brains of the maintenance system really is the CMC or central maintenance computer. The central maintenance computer allows us to divide the maintenance parameters and all the information we have into different folders within the system. Anywhere from exceedances down to chips, as much as continuous data monitoring, usage monitoring, recording drives temperatures over the period of the life of the aircraft so that you can get trending data. So I'm going to quickly show you the CMC logs. These are the CMC logs. So when I was talking about the different folders, you'll see the folders here. The first folder that pops up is your exceedance folder. That logs your exceedances if there were to be one. As you can see, there's nothing in our log here, so I can't click into it. But it will log your duration, your max and min of those exceedances. And you can go all the way down the system and look at the different folders and what there is there and offboard them manually or perform your maintenance here. So one of the unique features about the 525 is we have some cameras on here, and we can go to our GTC systems page and see various cameras on the aircraft. So that's the video capability. I know I could talk about this all day long and go into extreme detail, but now that I've covered the basics of the avionics on the 525, I'm going to turn it over to Christos, the avionics and safety supervisor up top.
Hello everyone, my name is Christos Bias and I have been in the program since the very early days. I can remember the unveiling at HAI, getting to watch first flight, and today I'm excited to talk to you about the 525. From the very beginning, the program has been designed with the customer in mind: safety and required redundancy, reliability, and maintainability. Today, I'm up on one of our platforms to point out a few items that are built into the aircraft for everyday use. Maintenance steps that are 6 inches wide to traverse the sides of the cowls. You can also maintain a positive handhold while accessing any of the doors up here. And the cowls that I'm standing on right now are even rated for 600 pounds. Maintainers also have access to built-in attach points such as this one for fall arresting equipment. My colleagues were explaining fly-by-wire and what it means to the pilot and the flight deck, but I want to talk a little bit about what it means to the aircraft. The 525 benefits from Bell's long lineage with advanced flight controls going back 35 years, all the way to the days of the V-22, the commercial derivatives, and now the 525. And then even looking forward, the lessons learned that we have here will be applied to the Bell 360 Invictus and the V-280 Valor. Adding fly-by-wire to this category and size of aircraft provides a few features over conventional control systems. If you consider for a moment the full controls from the pilot's hands to the rotating controls, fly-by-wire reduces the number of single-point failures such as bell cranks and control tubes. It also reduces the required provisions that would have to be put into the aircraft, from the built-in hardpoints, the tunnels, let alone just the space to route the controls from the flight deck all the way up to the roof. Down in the flight deck, in order to give the pilot that feel and feedback of being attached to the rotating system, since they're technically not, you have gradients and trim backdrive such that they can feel the response as if they were connected to the rotating system. So what is flight control systems on the 525? The 525 has a triplex architecture with 3 independent control channels. Looking down again at the flight deck, you have redundant position sensors for each of the pilot axes. And there's triplex arrangement for these that are made available to each flight control computer. What this provides is a very robust fault management architecture. Each flight control computer is able to receive all of these inputs and through a simple algorithm can monitor, and in the event of failures can seamlessly remove any of the failed components from the solution. Coming up to the roof deck, we have the triplex actuators. So one of them is housed here. So there are 3 of these. They're the 3 triple barrel actuators are positioned around the swash plate in order to provide the control to the rotating system. Keep in mind that with the triplex system, part of this is to manage failure modes. Each one of these individual barrels is able to handle the flight control loads. In the event of a failure, we could go down to a single barrel operating with the 2 of the lanes failed off and still have continued high flight and landing. Overall, the aircraft is designed to meet the civil requirements for certification. And a few other aspects of this, it allows for the integration of the advanced flight controls with the engine controls, allowing more responsiveness to the pilot demands to be coupled up with the FADA controls, as well as interfacing with the avionics flight deck. Some other aspects of the triplex architecture up on the roof deck have to do with the 3 independent hydraulic systems. So each system has been designed to reduce part count. So what that means to us on the 525 is the pump, the reservoir, and the manifold are all housed together into a single hydraulic unit. We call it the hydraulic power pack, of which there are 3, and each of those are spatially separated on the aircraft to provide system separation, and also to have them attached to different gearboxes for different failure mode mitigation. Each system is physically separated on the helicopter, including the routing and the interface of the hydraulic lines, as well as their matching command lines that come up from the flight control computers. All of this was put in mind with having to tolerate things such as single point failures or events external to the aircraft such as bird strike. So talking a little bit about the 525 electrical system is equally robust in its design. On this aircraft, we have dual main generators. In addition, there is a backup generator for emergency power. There's redundant and independent power to the flight control computers, and then there's an APU-driven generator for ground operations. With the engines being pneumatically started, there is no generators attached directly to the engine. This alleviates the concern that can happen with an engine failure causing a loss in electrical power. So as I explained a little bit about the certification aspect with the electrical system, I want to talk a little bit about ice protection. The 525 will be certified with an ice protection system on the aircraft. The design is well underway and will be part of a follow-on certification, where that'll consist of AC main generators and AC power provided to the aircraft. So tying it all back, the 525 aircraft brings together fly-by-wire and advanced flight controls. Together with those 2 aspects, this enhances the performance compared to conventional flight controls, reduces the pilot workload, reduces the flight safety part count and associated maintenance costs with all of those provisions, and increases the reliability via self-test and detection functions, which ultimately reduce the cost of maintaining the aircraft. On behalf of the team, it has been a pleasure to talk to you about the 525 today.
Hi, my name is Scott Poster. I'm the drive system lead for the 525, and I'm here today to talk about the drive system on the 525 and how it differs from everything else flying today. Unlike things you might be used to, the 525 takes the high-speed engine, and rather than going into the main rotor gearbox, it goes into 2 separate reduction gearboxes. These reduction gearboxes take the high speed from the engine and reduce it to less than 6,000 RPM before it ever goes into the main rotor gearbox. This is done with a simple 3-gear reduction. The gearbox is kept simple because of the high speed and only contains 3 gears, the bearings that support them, and an oil pump for each independent lube system for the 2 RGBs. From the RGBs, the power goes forward into the main rotor gearbox. The main rotor gearbox has nothing in it over 6,000 RPM and also eliminates the high-speed planetary. With the reduction of the high speed and the heat generator from the high-speed planetary, it greatly enhances the reliability of the gearbox. Some other differences in the main rotor gearboxes and the other gearboxes on the 525 that you might notice is we limited the penetrations into the main case. We took most of the sensors on the gearboxes that you might be used to and put them all on the easily replaceable filter head. This minimizes the penetrations into the main rotor gearbox and greatly reduces reasons maintenance is required and the possibility of having to remove the main rotor gearbox from the aircraft. Some other features of the main rotor gearbox include compartmentized chip detectors. There are 4 chip detectors dedicated to the main rotor gearbox alone. We also run very few accessories on the main rotor gearbox. There's only 2. The rest of the accessories run on the aircraft are done by independent accessory gearboxes, which we'll talk about in a minute. The main rotor gearbox has an oil sampling valve to monitor the quality of the oil in the gearbox. And in addition to the oil sight glass, we also have oil levels under glass in the cockpit. The main rotor gearbox is mounted in the aircraft by 4 live mounts. These are liquid inertia vibration mounts that limit the vibration from the pylon going into the airframe. To greatly limit the possibility of a loss of lube from occurring in the main rotor gearbox, we have eliminated all external lines and tubing from the main rotor gearbox. This also means that the cooler itself is mounted directly to the gearbox. In addition to this, and with all the other pressurized gearboxes on the aircraft, all pressurized oil transfer is done through oil transfer tubes in lieu of relying on compression to hold the oil pressure in place. This is really important because we could lose a fastener or even have a component crack and slightly translate off the gearbox, and oil pressure will be maintained within the gearbox. Let's move forward now and look at some of the aspects of the main rotor gearbox that you can see from the maintenance door and through the maintenance panel. While kneeling on the cowling with the maintenance panel open, from this vantage point I can easily see the oil filter and the filler cap. They're mounted high for ease of maintenance and accessibility. On the oil filter itself, I can see the impending and full bypass, the pressure regulator, the temperature sensor, and the pressure transducer. Also from here, I can see 2 of our chip detectors. I can see the chip detector for the mast and the chip detector for the planetary. These chip detectors were put here specifically so that I can access them to this maintenance panel, and if bore scoping is necessary, I can stand on this door, put a bore scope through the chip detector openings, and see the planetary, all the gears within the gearbox, and the lower mast bearing area. From here, let's talk about the accessory gearboxes. Unlike other aircraft, the accessories on the 525 are triple redundant. We have a lot of accessories, and in order to simplify the main rotor gearbox, we took as many as possible off the main rotor gearbox and put them on 2 separate redundant accessory gearboxes. These accessory gearboxes are kept as simple as possible. They're splash lube, they have no external cooling, and each contains 4 accessories, the gears that run the accessories and the bearings that hold them up. I want to make sure that it's really understood why we took the accessories off the main rotor gearbox. We want to keep it as simple as possible and eliminate all oil leak paths that we can. Taking the accessories off the main rotor gearbox and putting them on the accessory gearboxes moves the complexity of all those accessory drives and the oil seals that could leak off the main rotor gearbox and onto the redundant accessory gearboxes. This aircraft can continue safe flight with a total loss of one of the accessory gearboxes or a loss of a reduction gearbox. The next thing we're going to talk about is the tail rotor system for the aircraft. Now we've moved back to the tail of the aircraft to talk about the tail rotor drive system. The tail rotor drive system is made up of segmented tail rotor drive shafts, leading to an intermediate and a tail rotor gearbox. All was designed to work well in an adverse environment with minimal maintenance. The tail rotor drive shafts are composite tubes with titanium end adapters. The hanger bearings themselves are hybrid, designed for long-term between maintenance. The couplings are all titanium or stainless steel. The intermediate gearbox and the tail rotor gearbox are both self-contained pressurized gearboxes with no external cooling. Going back to the tail rotor gearbox and opening the access panel, from this vantage point, I can see the oil filler cap and the oil filter. Again, the oil filter has many penetrations on the easily removable and replaceable oil filter head in lieu of penetrations into the main housing. From this vantage point, I can see the impending bypass, the full bypass, the oil pressure switches, and the oil pressure transducer. Now I'd like to talk about the testing we have done to date for the drive system. To date, the drive system has passed thousands of hours of testing, including high power, low oil pressure, high temperature pressure, and loss of lube testing. In fact, all the primary gearboxes on an aircraft have demonstrated over an hour of loss of lube time with excellent results at the end. The accessory gearboxes being splash lubed, although they're not required to pass a loss of lube test, we have run for over 5 hours on our bench test with no oil in the gearbox. Let's pass it back to Byron for some closing statements.
Thank you for joining us today. I hope you have a greater appreciation for the design that went into the Bell 525. The 525 is the most modern commercial transport helicopter now and for the future. Safety and long-term capability is embedded in every design aspect of this aircraft. Thank you very much.